World War II left deep impressions everywhere, even on the ocean floor. Thousands of cargo and warships sunk during the conflict. New wrecks have joined older ones and have ended up on the seabed ever since humanity began its adventures on the sea. Each wreck is a fragment of history, which, when considered together with others, forms an extraordinary heritage of knowledge to study and preserve for future generations. Sea marauders have plundered and destroyed most of what was located within the depth reachable by scuba divers. But the vast majority of wrecks have been protected by their greater depth. It won't be safe much longer though, now that new underwater technologies are becoming more mainstream, thereby making it possible to reach those depths. The ARROS project was created to facilitate the location of the submerged heritage before it's too late, so that it can be periodically monitored and preserved. ARROS stands for Archaeological Robot System for the World's Sea. It is financed by the European Commission under the environment theme of the 7th Framework Program for Research and Technological Development. 10 partners, including universities, research centers, and private companies, have been involved in this project, coming from throughout Europe and coordinated by the University of Florence. Their specializations include underwater engineering, robotics, and visual engineering. The project kicked off in September 2012 and will end in August 2015. The objective is to construct low-cost mini-submarines able to autonomously scan the sea bottom without human intervention from the surface, and to explore large tracts of sea in a short time. Finally, a technology now used only in the military and in the gas and oil industry will be available to archaeologists all over the world. The use of an AUV, autonomous underwater vehicle, also avoids risks to the personnel, no longer employed in hazardous dives, but safely sitting at a table while downloading and analyzing all the data coming from the robots. To speed up the recognition phase and reduce the duration of the mission, the mini-submarines will swarm in formation. They will thus be able to communicate with each other, exchanging the acquired data and autonomously cooperating to the success of the mission. Once a robot spots an object of interest, it instantaneously alerts the rest of the swarm, so they can focus on analyzing the area. This is one of the most complex aspects of the ARRO project, since wireless communications are useless underwater. The researchers, therefore, use low-frequency acoustic transducers to create an underwater network. The mini-submarines will face very different situations depending upon the phase of archaeological research. The first phase, in fact, requires the rapid exploration of vast tracts of seabed in search of a wreck. The second phase kicks in once a wreck has been located. This phase calls for a highly maneuverable robot, capable of approaching the wreckage without stirring up silt, which would affect the capabilities of onboard cameras. The ARROS project plans to engineer a highly specialized AUV for each task. The Typhoon will have a powerful engine, large batteries, and heavy sensors, all the core requirements for exploration tasks. A second AUV, the Marta, will be equipped with a cleansing unit for archaeological finds. The A-size AUV will be engineered to be an even smaller mini-submarine, cheaper and easily transportable, suitable for smaller boat use with reduced personnel. The last one, the U-Cat, is a highly experimental biomimetic robot. Mimicking a fish, it is propelled by 4 fins and capable of moving with dexterity within the wrecks to capture videos and photos of the interiors. While construction continues on the vehicles, Arrow's researchers are working on the complex integration of optical images acquired by cameras with acoustic images captured by sonar. Their fusion will allow a virtual reconstruction of relics which archaeologists will be able to browse from their computer, as if they were themselves aboard the mini-submarine. To study the details of relics, archaeologists will use a high-definition 3D scan created by means of a laser blade, a technique used up to now only for surface scans. The researchers are also working on software capable of reconstructing a mosaic picture of the wrecks from the available video feeds, a method which will reduce the great amount of work needed today to produce this precious tool for archaeologists. The AUVs will be put to test in the Mediterranean and the Baltic Sea to test their ability of operating despite the presence of different currents, high or low temperatures, and various conditions of visibility. 2 seas very different from each other, but with one thing in common: the richness of the history of the boarding countries, a history part of which is still hidden below the seas. The future missions of Arrow's mini-submarines will not only be a technological challenge, but also a journey in search of the roots of European culture.